Good morning, student. Today we are going to learn about CMOS transmission gate. After the completion of today's session, you are able to explain the operation of CMOS transmission gate and draw different logic circuits using transmission gates. So, CMOS transmission gate consists of one NMOS and one PMOS transistor connected in parallel. So let's see the diagram. These are the symbols of transmission gate. In this symbol here you can see this one is the PMOS symbol and this one is the NMOS symbol, and they are connected parallelly. Okay, and these are the different representations of the CMOS transmission gate. Okay, so this one is the diagram. The gate voltages applied to these two transistors are also said to be complementary signal. So this one, if I give 1 here, then this one is the complement of this, means these are the gate signal, so they are here act as control signal. So whatever signal is given at the gate of the NMOS, just the complement of that given at the gate of the PMOS. So this one is the PMOS, this one is the NMOS. Okay, see here you can observe that. See, it is the control signal given to gate of the NMOS, and just complement, C complement is given to the gate of PMOS. Okay, so the CMOS transmission gate operates as a bidirectional switch between the nodes A and B, which is controlled by signal C. So this is a bidirectional switch. It is act as a switch. Okay, and this is a bidirectional switch, and these signals are act as control signal, which is controlled the flow of current. Okay, if the control signal, let's see this one C and C bar. Okay, if the control signal C is logic high, means 1, logic high, that is equal to VTD, then both transistors are turned on. As we know, NMOS turned on at logic high and PMOS turned on at logic low level. So when C equal to 1, then here C complement equal to 0. We know that, and that is given to the gate of the PMOS. Okay, so the both transistors are turned on at logic high and provide a low resistance current path between the nodes. As the transistors are turned on, so we can say current starts to flow, so low resistance current path is provided. Then when logic low level is applied, means when here 0 is applied, then at PMOS, that is C complements mean equal to 1. So both transistors will be off and the path between the nodes A and B, means this one A and this one B. Here you can see A, B and C, C bar. Okay, so the path between the nodes A and B will be an open circuit, means it is act as a switch. When the transistors are turned on, it is a closed switch. When the transistors are in off condition, that means it is in open condition. So this condition is called the high impedance state. Why high impedance state? Means there is no current flows through this. Okay, so let's discuss Okay, so this one is the C, here is the A, here is the B. So if we draw a truth table, at the input side we use two signal, that is A and C, and the output is B. Okay, so if we have two input signal, then we get 4 input combination. So when C equal to 0 and A equal to 0, means A equal to 0 and C equal to 0. If we give 0 as a control signal to the NMOS, we know that it remain in off condition, and the PMOS also in off condition, as here the complement is given, that is 1. So when the input combination is 0 0, that means output is high impedance state, means the circuit is remain in off condition. Okay, then the next input combination, that is 0 1. When 0 is given here, one second, when 1 is given here and C equal to 0, then also the switch remain in off condition, as 0 never able to turn on the NMOS, and the complement signal 1 is also cannot able to turn on the PMOS. So here also high impedance state. Then when 1 0 is applied, one second, then 1 0. So when C equal to 1 and A equal to 0, then when we give high logic to the NMOS, it becomes turn on, and also when 0 is given to the PMOS, it will be turned on. So at the output we get our signal, that is 0, the value of A. Okay, so here we get 0. Next last input combination is 1. So when A equal to 1 and C equal to 1, then we know that it is a conducting path can be established between A and B. So at the output we get 1. So this one is the truth table. But as we know here, one second, here two transistors are present. Okay, so when we give 1 here and control signal also 1, then both the signals both the MOSFETs are turned on. Then in which path 1 is transmitted and reached at the B point? As we know, NMOS is good to pass logic 0, but PMOS is good to pass logic 1. So here input is 1. So it choose the path of PMOS for transmission to give a better output. Okay, and when 0 is given, it select the path through NMOS to give a strong 0 at its output. Okay, it never pass through both the path, so it select as per the condition, that is PMOS is good to pass logic 1 and NMOS is good to pass logic 0. Okay, so this is all about transmission gate. Let's draw diagram using logic gates of this equation. So here the equation is AS bar plus BS. Here you can see AS dash is given, that is AS complement. Okay, So first we draw the symbol of transmission gate. Here bubble is given to represent PMOS and here NMOS. So here it is given AS bar. So at the input we take A and here we take S bar as control signal. As here we take S bar means here we write S. So at the output we get AS bar. Like this, again we draw another transmission gate. Here at the input we give B and S is given to the NMOS. So here S bar is given to the PMOS. So at the output we get BS. So we just simply combine this. So at the output we get AS bar plus BS. Like this, any equation given to you, you can easily draw the diagram using transmission gate. Let's do another example. This one, A B complement plus A complement B. Same thing, first draw the symbol, that is A is given here and B bar is given here. So here it is given B. So at the output we get A B bar. And another transmission gate is taken for the other term. So here we take A bar and here we take B. So here we take B complement. So at the output we get A bar B. When we combine this, at the output we get A B bar plus A bar B. Okay, it is very easy. So this is all about today's class. Thank you.